Good day, everybody. We're trying to show that an astronomically large number is a multiple of 3. And so I've written it, the first way I wrote it was just congruence arithmetic, modular arithmetic. This would read s minus 0 is a multiple of 3, but s minus 0 is just s. So these two statements are equivalent. M of course, is some integer. So we want to show s, the sum from 1 to 10,000 of the sum of the first of consecutive square odd numbers minus 2, okay? So anyway, what we're going to do is try to show that this green object is just a multiple of 3 and we'll be done. And the reason is that if you have, like let's say we have 3m1, just an example, 3m1 plus 3m2 plus 3m3 plus 3m4, m sub 3 plus 3 m sub 4. And I just arbitrarily picked 4, but notice this, of course, is the same thing as this is just equal to 3 times that sum, okay? M1 plus M2 plus M3 plus M4. Okay, so we're taking a scale on a much higher scale on the problem. There would be 10,000 of these multiples, right? 10,000. If we can show that this middle piece right here, this greened out piece, is a multiple of 3. So that's the task. If we can show the green part is a multiple of 3, we'll be done. All right, and so I've done most of the work for you right here, and I just restated what I just attempted to convey to you. We will show that this guy right here, that should be greened out also, is a multiple of 3. Okay. Now, this is all just a bunch of work. It's very straightforward, tedious, albeit error-prone, but 2k plus 1 quantity squared. This is the a plus b quantity squared result used twice. A plus b quantity squared. You guys know what I'm talking about. A plus b quantity squared. One or more, along with the difference of two squares identity, quite common in an algebra class. A plus b quantity squared by the distributive property. And no, I'm not going to use the word FOIL. We have a squared plus 2ab. Okay, plus b squared. Okay, and again, that got used, this identity got used 3 times. This very identity that holds for all real numbers got used 3 times, 1, 2, 3 times. And there are still teachers out there that FOIL, expand this out every time. You know, they don't trust these identities. They don't teach it to the kids, and so the kids don't understand the value of the identities. But the identities are computationally helpful, as in this case. Now notice right here we're almost done because there's certainly a 3 common to all of these terms. So we can write this as 3 times 4k squared plus, 12k? Plus 11. And so this is a multiple of 3. We've shown the green object, which is the sum in, is a multiple of 3. Okay? And again, hopefully it's convincing that showing that that is a multiple of 3 means you're just adding up 10,000 multiples of 3. And so we've proved what we set out to prove. All right? So we can write a QED right here if you feel like it. Again, I like these kind of problems. We could have probably tried a pure modular arithmetic approach on this thing, but in my view, it's just easier to directly, some people call this dumbassing. Don't try to use too much. If you can multiply it out in a fashion, you know, and directly show it's a multiple of 3, that's to me, that's a little bit more understandable than modular arithmetic from number theory. But in any event, we've finished the problem. Thank you for viewing.